In this example, sine of 2x minus x cosine x equals 0. We want to solve for x. We were also given that our parameters for x have to be between 0 and 2 pi. So what we're going to do at the very end is look at our unit circle, and between 0 and 2 pi we need to determine in radian form which values for x will work. So the first thing that I notice when I look at this problem is that I have a sine of 2x. Knowing my trig functions, I know that sine of 2x, I can rewrite that as 2 sine of x cosine x is the same thing as sine of 2x. So I'm going to replace that and say minus cosine x equals 0. By doing that, it's going to make the problem a lot easier to solve for x. So now I have 2 sine of x cosine x minus cosine x equals 0. Once again, I'm trying to solve for x. So looking at this problem now, I notice that I have a cosine x and a cosine x, so I can factor out that GCF. So my next line is going to be factoring out a cosine x. What's left over is 2 sine of x minus 1 is equal to 0. Now, because it is in its most factored form, I can set each thing that has an x equal to 0 and get my answers. So I can say cosine x is equal to 0, and 2 sine of x minus 1 is equal to 0. What I'm really saying, cosine x equals 0, is really, I could plug in my calculator, the arcsine of cosine equals 0. What values for x is going to give me 0? So I need to look at my unit circle. So what I'm going to do is look at my unit circle. What values for x are going to give me 0? I notice I'm looking from 0 to pi over 2. From 0 to 2 pi. So I notice that at 2 pi over 2, I have a 0 in the x-coordinate, and at 3 pi over 2, I also have a 0 in the x-coordinate, which deals with cosine. So my answers for that first one, cosine of x is equal to 0, means that x is equal to pi over 2 and 3 pi over 2. And that cosine of x equals 0 is solved for. Now the other one, 2 sine of x minus 1 equals 0, I want to add 1 to both sides and then divide both sides by 2. Now I want to go back to my trig function, my unit circle, and I want to determine what values in the y-coordinate, because that's what sine means, is going to give me 1/2. So going back to my unit circle, what values are going to give me a positive 1/2 in the y-coordinate? So I look in the first one, that positive 1/2 comes from pi over 6. And then once again, I'm looking again, and I notice I have that positive 1/2 from 5 pi over 6. 7 pi over 6 is not going to work because it gives me a negative 1/2. And 11 pi over 6 is also not going to work because it also gives me a negative 1/2. So my two answers are going to be x is equal to pi over 6 and 5 pi over 6. I could plug those in, and that should give me a true statement for sine of 2x minus cosine x equals 0.